Okay, g'day all. Welcome to another tute. Today I want to start coding, at least, the horizontal blur, which is the first part of the box blur in our x86 assembly. So this is going to be pretty scary stuff, I believe, and what I might do is just start programming it here in our box blur debug, and hopefully hopefully there'll be a few bugs as we go, but we can check all the bugs out and sort them out next tute maybe. I don't know if we'll get through the whole horizontal blur. It's not too much C++ code, but it is a fair bit of assembly, I reckon. So we'll see how we go. I've copied the C++ horizontal blur from the DLL source code down here to the bottom of my box blur debug assembly file. Just for a reference, just so I know what I'm doing. And there's 1,000,001 ways to do this. I'm probably not going to do it a very good way just here. What I'm going to do is more or less a straight one-to-one port from C++ to assembly. I think the first thing that we want to do is get our box blur working in assembly. It doesn't matter how slow it is. We want to get an SSE box blur working. So with that in mind, let's get started. Okay, so the first thing that I'll do is choose a few registers to use. I might use ECX as my Y counter. Yeah, I'll just make a note of that at the top here. Get out of the way. There's some sort of a... Okay, ECX is the Y counter. So I'll use ECX for my Y counter in the loops. We got an X counter. I might use EDX as the X counter. Although I think we're going to be calling IMAL, so I might not use EDX, since IMAL has a funny way of zeroing EDX. Is the X counter. We'll use R10D as our X counter, shall we? And then a few vectors. Okay, so I might use XMMO as my average and XMM1 as my temp. This might all change as well. I don't really know what I'm doing. XMMO is average and XMM1 is temp. Yeah, something like that should work out pretty nicely. So box blur width. What have we got here? I think the first thing that we should do is calculate this RCP box width, the reciprocal of the box width. I might do that with XMMO. And I might do it down here, since we've got blur width in EAX just there. Okay, so blur width times 2 plus 1. We're going to have to store this in a data segment. I mean, we don't have to, but I'm going to. So RCP box width, I'll call it. Even though it isn't actually... oops. It isn't actually the reciprocal of the box width, I don't think. Oh no, it is. Yeah, it is. It's not the reciprocal of the blur width though, it is the reciprocal of the box width. So we better copy our blur width into XMMO. So CVT SI to SS, that's convert scalar integer to scalar single, XMMO and EAX. Okay, so that's going to move blur width into XMMO low float. That's also going to cast it to a scalar single, and then we want to double it. So the easiest way to double a single is to... I might actually broadcast it first. So shuff PS XMMO XMMO and 0. So that's how you might broadcast your blur width to all 4 floats of XMMO. Now we could do that before or after, it doesn't really matter, but add PS XMMO XMMO. Let's double the blur widths, and then we've got to add 1 to it, or increment it, so that's going to be a little inconvenient. I might make up here 1s, real 4. Just make a little 1s vector. I might also put up here a line 16. Even though it will actually be a line 16, like the start of your data segment will be a line 16 just by the C++ compiler, I think. I think it's the C++ compiler that will align it. It doesn't really matter, but it will be aligned. Okay, so add PS, XMMO, and 1s. and that is an XMM word, PTR. Increment them. Notice my use of the pronoun because I've completely forgotten what we're incrementing. Oh, it's yeah, it's this blur width times 2, and then reciprocal. So RCP PS, XMMO, XMMO. Recip them. Alright, then we might just save that. So mov APS, it's aligned. RCP box width, I want to say. Is that what I called it? RCP box width. Yeah, that's the one. Okay, RCP box width and XMMO. Okay, so all of this code just here is calculate that. Yeah, alrighty, so that's used in our multiplication when we want to average things. Okay, is that about all we've got to do for that? I think it is, so we can get started with our loops. Okay, so the first one, the while loop, I might call this while loop, or HBlur while loop 1 maybe? I'll just call it HBlur while loop, yeah. HBlur, well you don't have to have capitals, HBlur while loop. Okay, so how is this going to work? Y equals 0 while y is less than height. Okay, so ECX is my y counter. I might XOR ECX and ECX, which is of course just 0 ECX. And it's got to equal 0 all the way up to height. Okay, so inc ECX and comp ECX and height. Hello. Okay, there's trouble. There's trouble. We better save our height and our width. I might say image height, dd and that, image width, dd and that. Okay, so RCX is actually our image height and RDX is our image width. So we better save that at some point before we start using them. Mov ECX, well it's the other way around. Image height ECX. And the other one is mov image width EDX. Yeah, so that'll be good. I might put braces around those since they're memory operands. Okay, so down here we can say comp EDX to image height and jump if it's less to HBlur while loop to there. Okay, so that'll give us that loop just there. So the first thing that we do in that loop is 0, the average. So let's just have a go at that. It's going to be XORPS, exclusive or packed singles, XMMO, XMMO, which is our average, 0, the average. And the next thing we do is start another loop, I think, for x equals negative blur width minus 1. Okay, so R10D was our x. Negative blur width minus 1 is the same as negative, and then in brackets blur width plus 1. So I might just morph R10D blur width. Is that a variable, or did I not save it? Yeah, that's a variable. That's a variable, alright. Okay, and inc R10D and neg R10D. Yeah, that's right. So set R10D to negative blur width plus 1, or minus 1 rather. Yeah, I might put that above actually, that comment. Okay, so that's what that is, and that's just going to set up our X counter, and it's got to count all the way up to blur width. So if I make another loop, I'll call this HBlur X loop 1. I think we've got 2 X loops here. Yeah, there's one there and there's one underneath as well. So we'll call this HBlur X loop 1, and what it's going to do is inc R10D, and it's going to comp R10D to blur width, and it's going to jump if it's less to H whatever this was. Whew. Okay, so far so good, I think. I've probably got bugs already. But what are we doing in this particular loop? Well, we're adding a pixel from the original image to the average, which is XMMO. Okay, so that's right in here. What we want to do, add a pixel. Add a pixel. It's going to be R10D RCX or ECX. ECX is the Y counter, R10D is the X counter, from original image to XMMO. I'm actually going to make a function to do this, I think, just to keep the code a little bit cleaner. I'm also going to completely ignore all sorts of calling conventions. I might just say add orig to XMMO. Yeah, something like that. That'll be the name of my function. So that's just going to add a pixel. Which R10 and ECX are pointing to proc and ret and here and NP. Okay, so add the pixel that R10D and ECX point to from orig image to XMMO. Yeah, so we could do a proper calling convention thing here and follow the C calling convention, but I think we mightn't end up even calling a function here. We might just inline this. So for now I'll just define my own calling convention, which is going to be this, basically, an implicit read of orig image, and we'll add it to XMMO. So the first thing that we want to do is test that ECX and R10D are within the bounds of the image. I might just well, comp ECX and 0 and jump if it's less to finished. Okay, so if we're outside the bounds of the image, we don't want to do anything. So R10D to 0 and the same, jump if it's less to finished. We want to comp ECX to image height and jump if it's greater or equal to finished. And we also want to comp R10D to image width and jump if it's greater or equal to finished. Yeah, so just make sure that our two little pixel offset references there are within the bounds of the image. I might just put braces around that to show that it's memory. And once we've done that, we can calculate the offset into the image that they actually point to. So how are we going to do that? I might mov EAX ECX, that's the Y value. I think I might imul EAX by image width. And then add EAX R10D. Yeah, that should give me the offset of the, well, that should give me the pixel number, but it's 16 bytes per pixel, so we'll also have to multiply that by 16, which is a left shift of 4. Sure, 4. Okay, and add PS XMMO, and where's my original image? Is it R8? Yeah, R8's pointing to my original image, so R8 and RAX. Well, there we go. That's an XMM word pointer as well. Okay, so that should add a pixel from the image that R10D and ECX are pointing to as offset pointers. I've used RAX down here, but I've actually done the arithmetic with EAX, and it's not going to matter. The top of EAX is going to be cleared by these 32-bit operations, so hopefully that won't really matter. I might just make a note here. This is add pixel to XMMO from orig. Okay, so far so good. Let's just scroll down and see what we're doing next. Okay, so we've done that. We've done that loop there, and we've done the average. The next thing that we've got to do is multiply that average that we've calculated so far in XMMO by RCP box width. So we saved that RCP box width already. Where are we? Are we outside of the... No, we're still inside the Y loop, but we're outside of the X loop, the first X loop. So down here, average the sum in, well, it's called average. I'll call it XMMO. It's going to be mul ps XMMO by XMM word. XMM word PTR what? RCP box width. Is it called RCP box width or RCP box blur width or something? Let me just scroll off the top again. RCP box width. Okay, so that's that average there. So the next thing that we've got to do is start up another X loop. So I'll call this X loop 2. Or what was it? HBlur X loop 2. Yeah, HBlur X loop 2. Yeah, just like that. And we might use R10 as our counter again. So we'll set that to 0, which is XOR R10 and R10. That's my X counter. And down the bottom, inc R10D, conf R10D to width, I think. Image width. Whoops. Image width. And jump if it's less to this place. Okay, that should just about do that. Is that right? Yeah, 0 to width. Okay, so the first thing that we want to do inside the second X loop is 0 the temp. Okay, so temp I think I said was XMM1. Let me just scroll up the top where I wrote that down. Yeah, XMM1 is temp. So we'll 0 temp. Where are we? Inc R10D. Oh, it's here. Okay. X or PS, XMM1, XMM1. That's 0 the temp. Good stuff. Okay, then we want to sub a pixel from original image. So that's pretty much exactly the same as the other procedure. Yeah, that's pretty much the same as the other procedure, only we've got XMM1 that we're writing to instead of original image. So let me just scroll up the top, and I might just make another procedure. So sub orig from XMM1, and we'll just call that. Now that X value is actually X minus blur width minus 1 that we actually want to subtract there. So I'm going to have to set that X counter up to be yeah, minus blur width and minus 1. I might just, before we call this sub EBX, no it's not EBX, it's R10D, the blur width, and deek R10D, but outside of that we better add them back on again. So add R10D and, well, it's this, and inc R10D. Okay, so sub orig from XMM1 is almost exactly the same as the procedure that we already wrote, which was add orig to XMMO. So I might just copy that. You're probably better off making a macro or something than yeah, these functions that are all almost the same, but I'm just going to do it like this. So add orig to XMM1. If we need to do a macro, if it's going to really help, then we can do it later. Okay, so the only difference is this, I think. Better change the comment as well. But there, so add orig to XMM1. No, we're making sub orig from XMM1. Sub orig from XMM1. Here we go. Let me just scroll down and see that we're calling the right thing. Where are we? It's there, sub orig from XMM1. Okay, so far so good. Okay, I didn't actually change that from add PS to sub PS, so I better do that. It's here. Yeah, add PS. That should be sub PS. But other than that, I think we're right to go on. So the next step is plus blur width. Yeah, okay, so what we want to do, I think, is we want to add blur width twice just here, so something like that. And then call another routine, which is add orig to xmm1, which we'll write in just a second, and after that sub from R10 blur width to get the R10x counter back to what it was. Now this is obviously a stupid way to do things, but hopefully you can see what I'm trying to do. This is just a straight port. Okay, so I'll just copy that, sub orig from xmm1. Actually, I might copy the other one. Add orig to xmmo, because what we're doing now is add orig to xmm1, which is almost the same, except we use xmm1 instead of xmmo. And let me just hit a 1 there. And that should just about do those two functions. And the next thing that we want to do is multiply that by RCP box width. Okay, so multiply temp by RCP box width. Temp is xmm1, so RCP box width. And that is an XMM word, PTR. Okay, which takes us to there. And then we need to add that to the average. And the average is XMMO, so add PS, XMMO, XMM1. I might just say here, multiply temp by RCP box width. And this is add temp to average. And all of this stuff up here was getting the the right pixels for this second box blur, second X loop. Alright, but after we've done that, we want to write the pixel. We want to write the pixel to HBlur. I might actually write it to front image. Yeah, so front image is the image that we can see, so we want to see what we're doing here in the hopes that we're doing it right. So I might say write XMMO to, well, I'll call it HBlur, but for the time being we'll write to front image. So I'll just copy that and paste it up the top here. We'll make another little function to output one of the pixels. So proc ret np, and this is going to be similar to before. So we've got all of the comparisons to make. This is a function that's going to write XMMO to the pixel that ECX and R10D point to. And this stuff is the same too, except for we don't write it to the same place. So if I just copy that, where's my... Oh, it's here. Okay, so we'll calculate the pixel offset in our front image once again with EAX, but MOV APS XMM word PTR. It's not a P. That's not a bracket. Okay, so we'll copy it to, we'll write it to R9 at the moment, which is front image, but really we will be eventually when we do the vertical blur as well, we'll actually change it and put it into HBlur. So for now it's that. I think should just about do the trick, and if I just put a comment here and say calculate the offset into the output image in EAX. Okay, yeah, that should just about do it. So if I just scroll down again,